Well, welcome back to these intro videos on formal logic. What I want to do in this video is go into the different kinds of connectives that we can have in formal logic. What do I mean by connective? By connectives, I mean the different ways that we can stick simple propositions together to form complex or compound propositions. Now, here's the different ways in which we can do this. Now, there's a more advanced stuff that we can do later on. Here's the most rudimentary way that I can render it. We have these kinds of statements. We have if-then statements. We have and statements. We have or statements. We've got this weird one here called if and only if statements. And then we've got nots, which is a weird category unto itself. Those are kinds of they don't seem like they're connecting things together, but they modify simple statements. So all these kinds of expressions that we use in English and in their various versions in other languages, these take simple propositions and modify them in some way. Now these have technical names too, and then I want to go over the symbolization for them. So if-then statements, technically those are called conditionals. Some people might call them implications, material implications, all that's fine. The symbol that I will be using in here for conditionals is an arrow, always pointing towards the right. There are some people that use arrows that point to the left. I'm not about that. Some people will use, instead, if you look this stuff up online or go to ProofWiki or something like that, some people will use this symbol. Some will call it the horseshoe. This thing drives me mad, because I can't remember, am I using the pointy end as the thing that's pointing, or am I using it like a magnet and that's the end that's pointing? And I can never remember, it always confuses me, so I hate it very, very much. So we will be using the arrow always pointing to the right to represent conditionals. So if I want to say something like, if A, then B, that will be rendered A, arrow, B. So whatever follows if goes on the left side of the arrow, and whatever follows the then goes on the right side of the arrow. There are other ways of talking about that too. Sometimes the then is not even there. Like, if we win, I'll be happy. I could say if we win, then I'll be happy, but the then sometimes is implied. That's why these are called implications. And these are called conjunctions. The symbol I'll be using for and statements, and there's more words for and than just and. We can have and, but, yet, moreover, nevertheless, nonetheless, and I'm sure other, although, also, these words can mean and. Conjunctions, the way that I'm going to represent it in here is with a big old dot center line. Now, some people will use, if you go online, you'll see some people will use, it looks like an upside down V. Other people will use an ampersand, which I won't even attempt to draw because it looks like a drunk person trying to draw an 8, so I'm not going to do it. The symbol I'll be using in here will be the dot. In your textbook, however, it will use the ampersand to represent conjunctions. Or is complicated because there are two kinds of ways of talking about or. There are, and these are disjunctions, what or statements are. Which can be inclusive or exclusive. So these are or statements, but there's two kinds of or statements, inclusive and exclusive. What does it mean for a disjunction to be exclusive? Is that you can have one or the other, but not both. So let's say for the sake of argument, that this class was not an online class, but an in-person class, and we meet on Tuesdays and Thursdays. If you find yourself falling asleep in this logic class, then you wake up and you realize you're in logic class, all the regular students are around you, you might conclude, well, if I'm in logic class, then today's either Tuesday or it's Thursday. However, that's an exclusive disjunction. There's no way it can be Tuesday and Thursday at the same time. So an exclusive disjunction is a way of saying it's one or the other, but it can't be both of them. You can't make a conjunction between the two things as well. It's exclusively one or the other. The But the symbol that we'll use to represent exclusive disjunctions will be this. I call it the sniper sight. It's basically a plus sign with a circle around it. Now, inclusive disjunctions. Those are simply disjunctions where it's not exclusive, but inclusive. You could have both. So you go into a restaurant and it says with your dinner you can have the soup or the salad. If you say, actually, you know what? I would like to have both the soup and the salad with my dinner. There might be an upcharge, but it's not as though, I think rarely is there going to be an instance where the server is going to say to you at that particular instance, no, you got to pick one, we can't do both. You could do both. And so therefore, even though there's a sense of choice, a conjunction could happen. Nevertheless, it's being rendered as a disjunction. Inclusive disjunctions will be represented with a symbol that looks like, kind of like a V, but I'll be calling it the wedge instead of just V. Now, how these things look, and I need to go back to my conjunctions as well. If I want to say something like A and B, great. A or B, inclusively. A or B, but not both, exclusively. And that brings us to this next weird phrase, if and only if. These are called biconditionals. There are other ways to say biconditionality instead of if and only if. Some people will abbreviate with IFF, if. Some people will say exactly if. Some people will say just in case. It's a weird phrase, and it's kind of a technical phrase, so we're going to get to this one later in the course, going over what biconditionals are. But for our purposes, basically, it's an arrow that goes in both directions. So if then this thing, but also the other way, if then this thing, and it works in both directions. How will that be represented? With an arrow that goes in both directions. Now, if you look online, sometimes you'll see people do this 3-bar symbol like that. I hate taking the time to write that, so I'll just be doing a double arrow. Sometimes people do an equal sign instead too. But it is kind of like a notion of equality in logic, but I'll explain that later. And then finally, the last one, not. These are negations. The symbol we'll be using for negations is the tilde. Some people call it the squiggle. That's fine. It's the squiggle that you see above the word jalapenos. So that symbol right there, the reason why I do that is sometimes when people want to write, and you might have done this yourself, sometimes let's say, I want you to write -2 instead of the number 2, numeral 2 I should say. People go, oh, I meant that too. No. The squiggle makes it very obvious that you mean not to. And that's exactly what we'll be doing with the squiggle or the tilde, is just saying it means not something. So putting the biconditional up here, if I want to say A, if and only if B, that would look like this. And then if I wanted to say something like not A, it's A with a not in front of it. And I could also negate any of these kinds of statements, but I have to negate the whole thing. So if I want to say not A arrow B, what would happen is I put parentheses around this and say not that. Because if I didn't, if I just stuck the not here, that's not, negations kind of mean the opposite of something, so that A, what's the opposite of that? Not A. Technically they're contraries and not opposites, but we'll use opposite for the sake of being a little colloquial. But if I stick a not in front of just this A here, this is not the opposite of this. But this affects the whole thing. Parentheses will let you know that whole thing there, that's what's being affected by this. Okay. The next thing I want to do is saying a couple of things about grouping these things together using parentheses and brackets and how we render these things diagonally. So that'll be the next thing I'll talk about.